Hello and welcome to today's class. I hope you have been enjoying the previous episodes. So today we have an exciting topic to discuss on Deliquescent, Efflorescent and Hygroscopy. Basically, Deliquescent are substances which when exposed to the atmosphere absorbs water and form solution. They absorb water and they form solution. Those substances that have the ability to absorb water and form solution when exposed to the atmosphere, we refer to them as deliquescents. For example, you have your sodium chloride. Sodium chloride is your table salt. You can do that experiment. Get 1 spoonful of sodium chloride and put it in a container. Keep it in any open place within your room or your house. Leave it there. Make sure there is no water around the environment. Just leave it there for like 4 to 5 days. By the time you come back in the 5th day, it must have turned to water. You'll be like, where did this water come from? It is a deliquescent. Now, other examples of deliquescents include, you have your sodium hydroxide, potassium hydroxide, iron 3 chloride. Iron 3 chloride. You have your calcium chloride, magnesium chloride. You also have your phosphorus 5 oxide, and silica gel. Silica gel. So these are examples of deliquescent substances. Then we move over to efflorescent. Efflorescent are substances which when exposed to the atmosphere loses some or all of its water of crystallization. So these are the substances, when you expose them to the atmosphere, they already have water of crystallization. So when you expose them to the atmosphere, they do what? They lose some or all of their water of crystallization. Example, you have your sodium triazocarbonate 4 decahydrates. Now this one, we also call it washing soda. We also call it washing soda. Sodium triazocarbonate 4 decahydrate. We also call it washing soda. We also have sodium tetraoxosulfate 6 decahydrates. This one is also known as global salts. Global salts. As you can see, they have water of crystallization. They have water of crystallization. So when you expose them to the atmosphere, what is going to happen is that they will lose some or all of its water of crystallization. Then you have sodium triazocarbonate 4, maybe with 1 molecule of water left, or sodium triazocarbonate 4 crystals remaining. Or when you expose them to the atmosphere, you have sodium tetraoxosulfate 6 with 1 molecule of water remaining, or you just have the crystals of sodium tetraoxosulfate 6. So these are examples of efflorescence. And the phenomenon is what we refer to as what? Efflorescence. Okay, now hygroscopy, these are substances which, when exposed to the atmosphere, absorbs water and becomes sticky. Now the difference between this and this is that this one absorbs water and forms solution. But hygroscopic, they absorb water and become sticky. Example, you know your Milo tea. When you get your Milo and probably you expose it to the atmosphere, or you didn't cover it with a tight fitting can, what happens is that after some time, when you come to take some Milo, you discover it is now sticky and become like Choco Milo. You can easily take it, it has caked. You can easily take it and then eat it as sweet. That phenomenon is what we refer to as hygroscopy. They don't form solution, they dissolve. They don't form solution, they become sticky. That phenomenon is what we refer to as hygroscopy. And the substances that undergo hygroscopy are referred to as what? Hygroscopic substances. So examples of substances that absorb water and become sticky when exposed to the atmosphere include, you have copper 2 oxide, you have sodium triazonitrate 5, and you also have your quicklime. Quicklime, that's sodium quicklime, that's calcium oxide. So these are hygroscopic substances. Please take note of where each of the substances fall on, because the examiner is going to ask you which of the following is not a deliquescent, which of the following is an efflorescent, or this phenomenon is referred to as what. So please take note of the substances and where they fall into. Then we move over to drying agents. Okay, so let's look at drying agents. Another name for drying agents is desiccants. Drying agents or desiccants are those substances that are used to remove moisture. You use them to remove moisture from substances. Moisture means water. Any substance that helps to remove water from another substance, we refer to it as a drying agent. They are used to dry gases. These drying agents are used to dry gases, and they are placed in the desiccator in the lab. They are placed in the desiccator in the lab in order to obtain substances in the dry form without moisture. So let's look at the drying agents we have. We have concentrated tetrazosulfates. These can dry all gases except ammonia and hydrogen sulfide. Now, when using drying agents, you have to be careful not to use it with a substance that it can react with. For example, if you put concentrated tetrazosulfates to dry hydrogen sulfide or to dry ammonia, it is going to form another substance. Like with ammonia, it's going to form ammonium tetrazosulfate 6. And that's not what you want. You want to obtain a dry ammonia. And now it is forming another substance. So you have to make sure that the drying agent you want to use dries that substance without reacting with it. So concentrated tetrazosulfates is going to dry all gases except ammonia and hydrogen sulfide. Then fused calcium chloride is going to dry all gases except ammonia. Calcium oxide, another name for this calcium oxide is quicklime. Quicklime is suitable for drying ammonia. Please take notes. This is examiner's favorite. Quicklime or calcium oxide is suitable for drying ammonia. Then phosphorus 5 oxide is suitable for drying all gases except ammonia. And silica gel dries all gases including ammonia. So the two suitable drying agents for ammonia include quicklime and silica gel. All right, we've come to the end of this class today. Thank you very much for joining us. Please do well to subscribe to our channel and invite your friends to do the same. Thank you very much. Bye.